Today we will solve systems of equations with three variables. So here's our first example. We have z equals 9x, 3x minus y plus 2z equals 13, and 2x minus y plus 2z equals 17. So you notice now we have x, y, and z. So we are looking for an x, y, z point. So we have z equals 9, so we already know one of them. So now we just have to plug that in to these other two equations and solve for x and y. So I have 3x minus y plus 2 times 9 equals 13. And then I have 2x minus y plus 2 times 9 equals 17. So I'm going to solve each equation here. Subtract the 18. And I have 3x minus y equals a negative 5. Then I'm going to solve the other equation here. Simplify it rather. Subtract the 18. Alright, so now I have two equations with two variables. That's kind of like what we've been working with all of last week. So I'm just going to move this over here to put them next to each other to see what we need to do to solve for x and y. Alright, so I could very easily use the elimination method with y if I multiply out a negative 1 here. And then I'll get negative 3x plus y equals 5. Negative y and positive y cancel out. I get negative x equals 4, or x equals negative 4. And then I can plug this in for this x here, and I get 2 times negative 4 minus y equals negative 1. Alright, 2 times negative 4 is negative 8, plus 8, plus 8. Negative y equals 7, or y equals negative 7. So now I have my answer, negative 4, negative 7, and 9. Sometimes, though, these equations aren't going to be set up really pretty for substitution. We're not going to have the value of one of the variables, just like when we have two variable systems. Sometimes we're going to want to use elimination. And that is what this one looks like. So in elimination, I'm trying to find where one of the three variables is going to be the easiest to eliminate. And I'm looking 2's and 3's. That's not going to be very easy, 2's and 3's, but 1's and 2's will be. So I'm going to set these two equations. Actually, let me do that in a different color. I'm going to put these two equations next to each other and try to eliminate y. And then I'm going to use these two equations and try to eliminate y. Alright, so let's start with the first two. So I'm going to take this top equation and multiply it by 2. That way I'll have a positive 2y and a negative 2y and they'll cancel. So that gives me a negative 4x plus 2y plus 4z equals negative 16. Now those will cancel and I'll get negative x plus z equals negative 2. Alright, so let's do the same thing with these two equations. Alright. So I'm going to multiply this equation by 2. And I'm going to get 6x plus 2y plus 2z equals negative 12. I'm going to bring this one under so it's easier to work with. And that gives me 3x minus 2y minus 3z, 14. The 2y's cancel. I get 9x minus z equals 2. Alright, now I'm going to put these two equations next to each other and see if I can eliminate another variable here. And I have a plus c and a minus c, so these will cancel. Make this part. These will cancel, and I get 8x equals 0. So now I know x equals 0. So if I plug that in here, and I say 9 times 0 minus z equals 2, 0 minus z equals 2, negative z equals 2, so z equals negative 2. Then I plug both of this x and this z into one of my original equations, and I get negative 2, I'm just going to go to the top one, times 0 plus y plus 2 times negative 2 equals negative 8. So that's just 0, that's gone. Y minus 4 equals negative 8. Y equals negative 4. So then our answer ends up being x was 0, y was negative 4, and z was negative 2. If you would like more practice on this, you can definitely go to IXL underneath Algebra 2, sections E12. E12 will go over 3 variable systems with substitution, and 13 will be 3 variable systems with elimination. See you in Zoom.